Welcome everyone in this part.
Question number 1. In reinforced cement concrete structures, the steel reinforcement consists of option A deformed bars, right, option B cold twisted bars, right, option C mild steel and medium tensile bars, right, option D is right answer, all of these, because all these types of steel reinforcements are used in reinforced cement concrete structures. Question number 2. A twisted bar has about 50% more yield stress than ordinary mild steel bar. Option D is right answer because of its twisting power. Question number 3. The compressive strength of concrete is about 10 to 15% of its tensile strength. No, the tensile strength of concrete is about 10 to 15% of its compressive strength. Option B is right answer, false. Question number 4. In singly reinforced beam, steel reinforcement is provided in tensile zone. Option A is right answer. This is a RCC beam of dimension D into B, and this is neutral axis. Above this neutral axis, this zone is compressive zone, and below this neutral axis, this is tension zone. Okay, and if the reinforcements are provided only in the tensile zone, then it is called singly reinforced beam, and if the reinforcements are provided in both the zones, then it will be called as doubly reinforced beam. Question number 5. In a simply supported reinforced concrete beam, the reinforcement is placed below the neutral axis. Option A is right answer. Question number 6. The joint action of steel and concrete in reinforced concrete section depends upon the option A bond between concrete and steel bars, right, option B absence of corrosion of steel bars embedded in the concrete, right, option C practically equal thermal expansion of both concrete and steel, right, option D is right answer, all of the above. Question number 7. In a singly reinforced beam, the effective depth is measured from compression edge to the center of the tensile reinforcement. Option B is right answer. This depth, this effective depth from the top of the beam to the center of the tensile reinforcement, this depth is called effective depth. Question number 8. Analysis of reinforced concrete can be done by option A straight line theory, right, option B elastic theory, right, option C ultimate load theory, right, option D is right answer, all of these. Straight line theory, elastic theory, they are also called working stress method of design, and ultimate load theory means limit state method of design. Question number 9. The application of elastic theory to the beam is based on the assumption that option A at any cross section the plane section before bending remain plane after bending, right, option B all tensile stresses are taken up by reinforcement alone and known by the concrete, right, option C steel reinforcement is free from initial stresses when it is embedded in concrete, right, option D is right answer, all of the above. Question number 10. In case of a cantilever beam, the tensile zone is above the neutral axis. Option A is right answer, A agree. Question number 11. If sigma CBC is the permissible stress in compression due to bending in concrete in Newton per millimeter square, the modular ratio AM is of the order of option A is right answer, 280 divided by 3 into sigma CBC. Question number 12. When the load on the reinforced concrete beam is so small that the tensile stresses set up in the concrete below the neutral axis is smaller than the permissible, then the concrete area below the neutral axis will not crack. Option B is right answer. Question number 13. In a single reinforced concrete beam, if the load is very small, only concrete will resist tension. Option A is right answer. Question number 14. The modular ratio is the ratio of Young modulus of steel to the Young modulus of concrete. Option A is right answer. Question number 15. In a reinforced concrete column, the cross-sectional area of steel bar is AS and that of concrete is AC. The equivalent area of the section in terms of concrete is equal to, option B is right answer, AC plus M into AS, where M is the modular ratio. If we multiply the steel area with modular ratio, then we will get equivalent concrete area of the 10 reinforcements place. Question number 16. In a singly reinforced concrete beam, as the load increases, only steel bars will resist tension. Option B is right answer because we know concrete is weak in tension. Question number 17. The stress in concrete increases in direct proportion to increase in strain. Yes, option A is right answer. Up to elastic limit, stress is directly proportional to strain. Question number 18. Normally, the tensile strength of concrete is about 10 to 15% of its compressive strength. Option A is right answer. Question number 19. If the load on the beam is increased, the tensile stress in the concrete below the neutral axis will increase. Option B is right answer. Question number 20. Under normal loading condition, the tensile stress set up in the concrete will be more than the permissible stress. Option A is right answer. Question number 21. A reinforced concrete beam will crack if the tensile stress set up in the concrete below the neutral axis is more than the permissible stresses. Option B is right answer. Question number 22. In a singly reinforced beam, the depth of neutral axis below the top of the beam NC is given by. Option A is right answer, where M is the modular ratio, sigma CBC is the compressive stress in extreme fiber of concrete, sigma ST is the tensile stress in steel reinforcement, and small d is the distance between top of the beam and center of the steel bars, which is known as effective depth. Question number 23. If the breadth of a single reinforced beam is B, effective depth is D. Depth of neutral axis below the top of the beam is N, and compressive stress in the extreme fiber of concrete is sigma CBC. Then the moment of resistance of the beam is equal to. Option C is right answer, sigma CBC by 2 into B into N within bracket 3D minus N by 3. Question number 24. The lever arm in a single reinforced beam is equal to D minus N by 3. Option C is right answer, which is equal to 3D minus N by 3. And lever arm is the distance between compressive force and tensile force, where small d is the distance between top of the beam and center of the steel bars, and n is the depth of neutral axis below the top of the beam. Question number 25. In a beam section, if the steel reinforcement is of such a magnitude that the permissible stresses in concrete and steel are developed simultaneously, the section is known as. Option A balance section, right. Option B critical section, right. Option C economical section, right. Option D is right answer, any one. Question number 26. The section in which concrete is not fully stressed to its permissible value, when the stresses in steel reaches its maximum value, then it is called under reinforced section. Option A is right answer. Question number 27. The actual neutral axis of an under reinforced section is above the critical neutral axis of a balance section. Option A is right answer, correct. Question number 28. The neutral axis of a balance section is called critical neutral axis. Option B is right answer. Question number 29. The moment of resistance of an under reinforced section is computed on the basis of tensile force developed in the steel. Option B is right answer. Question number 30. In a singly reinforced beam, if the stress in concrete reaches its permeable limit later than the steel reaches its permissible value, then the beam section is said to be under reinforced. Option A is right answer, true. Question number 31. If the tensile stress in steel reinforcement is sigma st, area of tensile reinforcement is ast, the depth of neutral axis is n, and effective depth is d, then moment of resistance of an under reinforced section is equal to sigma st into st within bracket 3d minus n by 3. Option C is right answer. Question number 32. In an over reinforced section, steel reinforcement is not fully stressed to its permissible value. Option A is right answer. Question number 33. For an over reinforced singly reinforced rectangular reinforced concrete section, the maximum stress developed by concrete will be equal to allowable stress in concrete. Option C is right answer. Question number 34. The moment of resistance of an over reinforced section is determined on the basis of compressive force developed in the concrete. Option B is right answer. And the moment of resistance of an under reinforced section is determined on the basis of tensile force developed from the steel reinforcement bars. Question number 35. The neutral axis of an over reinforced section falls below the critical neutral axis of a balance section. Option B is right answer. Question number 36. For a balance section, the moment of resistance obtained from compressive force will be equal to the moment of resistance obtained from the tensile force, because both will be equal for balance section. Option C is right answer. Question number 37. As the percentage of steel in the beam increases, the depth of neutral axis also increases. Option A is right answer. Question number 38. For a balanced reinforced section, the depth of neutral critical neutral axis from the top of the beam is given by the relation. Option A is right answer. M sigma CBC by sigma ST equal to NC by D minus NC. Question number 39. In the effective depth of a single reinforced rectangular beam is 300 mm. The section is over reinforced and the neutral axis is 120 mm below the top. If the maximum stress attained by the concrete is 5 Newton per millimeter square and the modular ratio is 18, then the stress developed in the steel will be 135 Newton per millimeter square. Option B is right answer. Question number 40. When a beam is loaded with transverse load, the bending moment varies from section to section. Option B is right answer. Question number 41. The maximum shear stress in a reinforced concrete beam of with B and subjected to a shear force F is equal to 3F divided by B into 3D minus N. Option C is right answer. Question number 42. Which of the following statement is about the percentage of tensile steel required to produce a balanced reinforced concrete section is correct? Reduces as the yield strength of steel increases. Option A is right answer. Question number 43. Which of the following statement is correct regarding the working stress method of design of under reinforced concrete section? Option A. The neutral axis depth will be greater than that of a balanced section. No, it will be less than that of a balanced section. Option B. The stress in steel in tension will reach its maximum permissible value fast. Right. Option C. The moment of resistance will be less than that of a balanced section. No, the moment of resistance will be more than that of a balanced section. Option D. The concrete on the tension side is also to be considered for calculating the moment of resistance of the sections. No, the steel will be used for calculating moment of resistance of the section. Question number 44. If the modular ratio is M, effective depth is D, and stress ratio is R equal to sigma ST by sigma CBC, then depth of neutral axis NC of a balanced section is M by M plus R into D. Option B is right answer. Question number 45. The D beams are designed for bending moment only. Option B is right answer. Question number 46. The maximum permissible shear stress given in IS 456/1978 is based on diagonal tension failure. Option A is right answer. Question number 47. When the lever arm of a reinforced concrete beam is Z and width of beam is B, then the maximum shear stress in a beam subjected to shear force F will be equal to F by B into Z. Option B is right answer. Question number 48. Shearing stress in the beam are not caused by the variation of bending moment along this span. No. Option B is right answer. False. Question number 49. In a reinforced concrete beam, the shear stress distribution above the neutral axis follows a parabolic curve above the neutral axis and rectangular curve below the neutral axis. Option C is right answer. Question number 50. The maximum shear stress in a rectangular beam is 1.5 times the average shear stress. Option C is right answer. Question number 51. Which of the following section of equal cross-sectional area can resist the torsional moment of a RCC beam section more efficiently when working stress design is adopted? Option C is right answer. A solid rectangular section. Question number 52. For a reinforced concrete beam section, the shape of the shear stress diagram is parabolic above the neutral axis and rectangular below the neutral axis. Option B is right answer. Question number 53. The chances of diagonal tension crack in RCC member reduces when axial compression and shear force act simultaneously. Option D is right answer. Question number 54. The diagonal tension in concrete can be resisted by providing diagonal tension reinforcement. Option A is right answer. Question number 55. Shear reinforcement is provided in the form of option A vertical bars right, option B inclined bars right, option C combination of vertical and inclined bars right, option D is right answer all of these. Question number 56. For M15 grade of concrete, shear reinforcement is necessary if the shear stress is more than. So near option is A 0.5 Newton per millimeter square. Question number 57. For M15 grade of concrete, the section is to be designed if the shear stress is more than. Option D is the near option. to n Newton per millimeter square. Question number 58. The section is to be redesigned if the shear stress is more than 0.4 sigma CBC, where sigma CBC is the compressive stress in the concrete. Option A is right answer. Yes. Question number 59. Which of the following statement is correct? Option A. Diagonal tension is caused by the combined action of longitudinal tension and transverse shearing stresses. Right. Option B. Shear reinforcement in the form of vertical bars is known as sit-ups. Right. Option C. According to IS 456 1978, if the shear stress is less than the 1/10 of compressive stress sigma CBC in concrete at extreme fiber, no shear reinforcement is necessary. Right. Option D is right answer. All of the above. Question number 60. At the center of the beam, the shearing stresses are practically negligible. Option B is right answer. False, because it is maximum at the center. Question number 61. The center to center spacing of vertical sit-ups in a rectangular beam is increased towards the center of the span of the beam. Option A is right answer. Question number 62. The spacing of vertical sit-ups in a rectangular beam is minimum near the supports. Option B is right answer. Question number 63. The number of stirrups resisting shear force in a reinforced beam is given by lever arm by spacing of the stirrups. Option B is right answer. Question number 64. A stirrup consists of 5 to 12 mm diameter mild steel bars bent around the tensile reinforcement. Option B is right answer. Question number 65. According to IS 456 1978, the spacing of stirrups shall not exceed a distance equal to the lever arm of the resisting moment. Option A is right answer. Question number 66. The torsion resisting capacity of a given reinforced concrete section increases with increase in stirrup and longitudinal steels. Option D is right answer. Question number 67. When the steel bars are embedded in concrete, the concrete after setting adheres to the surface of the bars and thus resists any force that tends to pull or push this rod. The intensity of this adhesive force is called bond stress. Option A is right answer. Question number 68. The longitudinal shearing stress acting on the surface between the steel and concrete are called bond stress. Option A is right answer. Question number 69. The bond between steel and concrete is mainly due to the option A pure adhesive resistance, right. Option B frictional resistance, right. Option C mechanical resistance, right. Option D is the right answer. All of this. Question number 70. Pure adhesive resistance in a reinforced concrete structure is provided by a relatively weak adhesion of the chemical gum produced by concrete during setting. Option C is right answer. Question number 71. Frictional resistance in a reinforced concrete structure is provided by the shrinkage of concrete. Option A is right answer. Correct. Question number 72. When a reinforced concrete structure is loaded, the resistance first broken is pure adhesive resistance. Option A is right answer. Question number 73. The hooks and other means of anchoring steel bars do not prevent the initial slipping of reinforced concrete structure. Option A is right answer. Question number 74. The term bond is used to describe the means by which slip between steel and concrete is prevented. Option C is right answer. Question number 75. Which of the following statement is wrong? Option A. The hooks and other means of anchoring do not delay the collapse of the structure. Right. Option B. The frictional resistance is high for smooth bar surface. Right. Option C. In the case of deformed bars, adhesion and friction become major elements. Right. Option D is right answer. All of the above. Question number 76. If L is the lever arm in reinforced concrete beam, S is the total perimeter of the steel bars, and F is the shear force, then bond stress developed in the concrete around the steel reinforcement is equal to F divided by S into L. Option C is right answer. Question number 77. As per IS 456 1978, the permissible value of bond stress for M15 grade of concrete is limited to. Near option B is right answer. 1 Newton per millimeter square. Question number 78. If the bond stress developed in a reinforced concrete beam is more than permissible value, it can be brought down by option A increasing the depth of the beam, right. Option B increasing the number of bars, right. Option C decreasing the diameter of the wires, right. Option D is right answer. All of these. Question number 79. If phi is the diameter of reinforcing bar, then for M15 grade of concrete, the bond strength used for splicing bar in tension is approximately equal to 8 phi. Option C is right answer. Question number 80. For reinforcing bars in compression, the average bond stress can be increased by 25%. Option B is right answer. Question number 81. When hooks are formed in deformed bars, the initial radius of the bend should be at least 3 times the diameter of the bar. Option B is right answer. Question number 82. In the above question, the length of the straight bar beyond the end of the curve should be at least 4 times the diameter of the bar. Option C is right answer. Question number 83. In case of deformed bars, the value of bond stress for various grades of concrete is greater by 20% than plain bars. Option B is right answer. Question number 84. The deformed bars may be used without hook, provided anchorage requirements adequately met with. Option A is right answer. Yes. Question number 85. Bars of tensile reinforcement of a rectangular beam. Option A are curtailed when not required to resist bending moment. Right. Option B are bent up at suitable places to serve as shear reinforcement. Right. Option C are maintained in the bottom to provide at least the local bond stress. Right. Option D is right answer. All of the above. Question number 86. When the diameter of a reinforcement bar is 5, the anchorage value of hook alone is equal to 16.5. Option C is right answer. Question number 87. The length of lap for reinforcement bars in tension shall not be less than 5 sigma s divided by 4 tau bd or 35. Whichever is greater. Option D is right answer. For 5 is the bar diameter, sigma s is the actual tensile stress in the bar, and tau bd is the permissible average bond stress. Question number 88. The length of lap for reinforcement bars in compression shall not be less than 5 sigma s divided by 4 tau bd or 24 5, whichever is greater. For sigma s is the actual compressive stress in bar. Question number 89. The maximum spacing of vertical reinforcement in RCC wall should not exceed 3 times the thickness of the wall. Option D is right answer. Question number 90. The measurement of anchorage lengths of inclined bars used to act as reinforcement is taken in tension zone free from end of sloping portion of the bar. Option A is right answer. Question number 91. The minimum spacing between horizontal parallel reinforcements of the same diameter should not be less than the diameter of the bar. Option A is right answer. Agree. Question number 92. Generally, the left slash splices in tensile reinforcement are not used for bars of more than 50 mm diameter. Option B is right answer. False. Question number 93. Which of the following statement is correct? Option A. The anchorage value of hook is assumed 16 times the diameter of the round bar if the angle of bend is 45 degree. Right. Option B. Steel bars are generally connected together to get greater length than standard length by providing hook splice. Right. Option C. For plain mild steel reinforcing bars, when hooks are used, they should be of U type. Right. Option D is right answer. All of the above. Question number 94. In a doubly reinforced beam, steel reinforcement is provided in tensile zone as well as in compression zone. Option A, B both are right. Option D is right answer. Question number 95. A doubly reinforced section is used. Option A, when members are subjected to alternate external loads and bending moment in the section reverses. Right. Option B, when members are subjected to loading eccentric on either side of the axis. Right. Option C, when the members are subjected to accidental lateral loads. Right. Option D is right answer. All of the above. Question number 96. The theory of doubly reinforced section is based on the same assumption as for singly reinforced section. Option A is right answer. Correct. Question number 97. In doubly reinforced rectangular beam, the allowable stress in compression steel is less than the permissible stress in tensile steel. Option B is right answer. Question number 98. A doubly reinforced beam is considered less economical than a singly reinforced beam because compressive steel is understressed. Option B is right answer. Question number 99. If the effective depth of a doubly reinforced concrete beam is small d and maximum stress in steel of concrete is sigma st and sigma cbc respectively, then neutral axis depth factor k is given by. Option B is right answer. M sigma cbc divided by m sigma cbc plus sigma st. Question number 100. In a doubly reinforced concrete section, the presence of steel bars in compression zone does not affect the depth of neutral axis. Option B is right answer.